Hello and welcome to another one of these ADD videos. Today we're going to look at a couple examples of Lewis structures that are a little bit more complex but not too difficult. Alright, so the first one is water, common substance all over our planet, and our valence number for oxygen, if you look it up on the periodic table, would be 6 because it's in the 6th column. And then we have hydrogen, which is 1, but there's 2 of them, so that gives us a total of 8 electrons to work with. So when we draw the skeleton structure, you have something like that because the hydrogen can never be central. And then your first attempt, you draw one bond and one bond here because that's all hydrogen can do. So if you subtract the 4 bonding electrons you just drew, you should be left with 4 lone pair electrons. Where is the only place we can put these lone pair electrons? Around the oxygen. Okay? So that would be valid structure. Let's check the formal charges. Formal charge for the oxygen would be 6 valence minus 2 bonds plus 4 lone pair electrons. 2 bonds. 1, 2, 3, 4. So that gives you 6 minus 6, which is 0. Formal charge for the hydrogen is, oops, my brain was copying and pasting, it seems. 1 minus the 1 bond plus 0 lone pairs. So they all match up. Alright, let's look at this compound here. This is formaldehyde, the most basic aldehyde. You guys will get into aldehydes that take organic chemistry later on. But here, if we count up, we should have 4 for carbon, 6, and then 1. So we got 4 plus 2 times 1, because there's 2 hydrogens, and then plus 6. So that's going to be 12. So when I arrange, carbon enjoys being central, so I'm going to put carbon in the middle. And I'm going to put oxygen as a peripheral element here. So then we know that hydrogen can only form 1 bond, so let's go ahead and draw those in there. And then if I put 1 bond here for the carbon, right now carbon hasn't got a full octet. So what I could do is I could add up a couple lone pairs, or I could add a bond. Now when I add a couple lone pairs, you'll see that carbon doesn't like lone pairs typically. It'll acquire charge, and if it did have lone pairs, this is what the formal charge would be for carbon. It would be the valence of 4 minus the 3 bonds plus the 2 lone pairs. You can see we'll have 4 minus 5, or a -1 charge. If you remember, we want our negative charges on elements like oxygen that are more electronegative. So let's try a double bond. Let's see how that works. And when we do so, we now have used 8 bonding electrons. Carbon's got a full octet, it's happy. Oxygen's not completely full, but let's see what we can do with these lone pairs. So we got 12 minus 8 gives us 4 lone pairs. So if I put 2, 4 right there, let's see if our formal charges work out. 4 valence, 4 bonds. That's neutral, good. Formal charge for the oxygen is 6 valence. It's got 2 bonds plus 4 lone pair electrons, which is also neutral, great. And then for the hydrogen, that is going to be 1 minus 1 bond plus 0, which is also 0. So, yep, that's a valid structure. All right? So, you can see how sometimes we need to add extra bonds in order to satisfy our requirements. All right? So, make sure you check out the more advanced examples. I'm going to be doing ions and the expanded octet rule. Basically, that states any element that's a central atom that's on the 3rd row or below, because it has access to the d orbitals, you can have what's called an expanded octet. And that expanded octet is basically allowing you to get more than 8 electrons on the central atom. All right? So practice, practice, practice. Thank you and have a nice day.